7.2 notes similar polygons. Definition of similar polygons. Two polygons are similar. The symbol for similar is 1, cheesy poof. Two polygons are similar if and only if their corresponding angles are congruent. Well, let's mark that. Let's say that B corresponds to C, and let's say that I corresponds to A, and let's say that K corresponds to R, and let's say that E corresponds to T. If their corresponding angles are congruent and the measures of their corresponding sides are proportional. Corresponding sides proportional would mean, like if you take BI and make a ratio with its corresponding side CA, whatever that ratio is, it's going to be the same as the ratio of IK to AR, which will be the same ratio as KE to RT, which will be the same ratio as BE to CT. So if corresponding angles are congruent and corresponding sides are proportional, then that means that figure bike is similar to figure cart. Definition of similar polygons. In a coordinate plane, as far as transformations go, this would mean that one figure was dilated to get another. The pre-image is dilated to get the image. Similar polygons are a result of dilations. Scale factor. Let me just take these two pictures. The ratio of lengths of two corresponding sides of similar polygons. So let's say in these polygons, this was a 2 and this was a 3. And you were asked for the scale factor of polygon, nice K, of polygon bike to polygon cart. To find that scale factor, you got to take one side of bike and put it over its corresponding side of cart. Notice bike was first, bike's on top. It's not a coincidence. So we know that one side is 2, its corresponding side is 3. The scale factor is 2/3. Next problem, determine whether each pair of figures is similar. Justify your answer. Well, first of all, corresponding angles have to be congruent. And it looks like that's true. Second of all, corresponding sides have to be proportional. Let's see if that's true. 2 corresponds to 3. 1.6 corresponds to 2.4. 1.8 corresponds to 2.7. Are all these fractions the same? I wrote 3 over 3. I should have wrote 2 over 3. Well, let's reduce each of these fractions. 2/3 is already reduced. Having a decimal in your fraction, not a good idea. I'm going to multiply this middle fraction by 1 in the form of 10 over 10. 10 divided by 10 is 1, so I'm not changing its value. The reason I'm choosing 10, because multiplying by 10 moves the decimal place 1 place to the right, so I'm going to get 16 over 24. I'm going to also multiply the fraction on the right by 1 in the form of 10 over 10. It's going to give me 18 over 27. 16 over 24, you can divide the top and bottom by 8 and get 2/3. 18/27, you can divide the top and bottom by 9 and get 2/3. Since each of the ratios simplify to the same thing, means corresponding sides are in fact proportional. So the question was, determine if they're similar, justify your answer. There's 2 things we're supposed to do. So, yes, they are similar. And the reason? We are going to just basically state the definition of similar polygons. Yes, they are similar because corresponding angles are congruent and corresponding sides are proportional. You need to say both of those things. You must include the words corresponding. Number 2. Right away we can say, no, corresponding angles are not congruent. I'll show you that here. We don't need to check the sides if the angles don't work. This angle, this first triangle has an angle of 90. The second one doesn't have one that's 90. So corresponding angles could not be congruent. So that's why we can say no right away. 3 and 4, draw and label a pair of polygons for each. If it's not possible, write Mission Impossible. 2 pentagons that are similar. A pentagon has 5 sides. So I can draw any kind of pentagon I want. To make this less work, I'm going to make this a regular pentagon. Regular means all the sides are the same length. And it means all the angles are congruent. You don't have to draw a regular pentagon. I just did it. If I draw another pentagon that's regular, it's going to be similar. Corresponding angles are the same. Corresponding sides are proportional. Scale factor here is 2 to 1. Pre-image is twice as big as the image. 2 squares that are not similar. Give yourself a minute and think about that. You'll find that that is not possible. By definition, a square has 90-degree angles. So if you draw another square, it has 90-degree angles. By definition, if you draw a square, all the sides are the same length. If you draw another square of random length, they're all the same. Comparison of 2 sides is 4 to 7 every time. That's why that's not possible. Number 5, 2 similar polygons are shown. Find the value of x and y. If your pictures are not drawn in such a way that corresponding parts are in the same positions, you better redraw one of your pictures. I'm going to redraw this one. I'm going to put 2 arcs in the top left like this one has, 90 in the bottom left like this one has, 1 arc in the bottom right like this one has. In between 90 and 2 arcs is x. In between 90 and 1 arc is 3. In between 1 arc and 2 arcs is y. Now if the polygons are similar, as it says, that means that corresponding sides are proportional. So I'm going to first start out by picking 2 sides that have numbers. So 6 is to 3 as 10 is to x. I could also make the equation 6 is to 3 as 8 is to y. The fraction 6 over 3 reduces to 2. If I wanted to multiply both sides by x to get rid of my fraction, I get 2x is 10. If I divide both sides by 2, we get x is 5. If I do a similar thing on this fraction, I'm going to get 2 is 8 over y. If I multiply both sides by y, I get 2y is 8. Divide both sides by 2, and I get y is 4. So find the value of x and y, 5 and 4, dunsies. Now this is a problem that I regret drawing. So, long story short, I accidentally made these rectangles. Why is that a big deal? Well, it's a big deal because I don't know if 5 corresponds to 18 or if 5 corresponds to x. That's why it's a big deal. So let's just make the wild assumption that the similar markings go together. So like this says 90 and this says 90. Now it's true this is also 90, but let's just put the 90s together. So let me redraw this down here. So we got 90, 2 arcs, 90, 2 arcs. Once again, this problem's kind of broke. You could get 2 different answers and still be correct. So maybe it's great. It means if you do it the way I didn't intend, I can't count it wrong because there's 2 different ways to do it. So between 90 and 2 arcs is x. Between 2 arcs and the 90-degree block is 18. And then between 90 and the 2 blocks is y. So since this ends up being a rectangle on accident, opposite sides are the same length. So we could make a proportion 12 is to 18 as 5 is to x. 12 over 18 reduces, divide the top bottom by 6, and you get 2/3. Could multiply both sides by 3 and x to get rid of our fractions. And that's going to give us 2x equals 15. Divide both sides by 2, and you get x is 15 over 2. Since this is a rectangle, that means that y is also 15 over 2. So once again, this problem's slightly messed up, which I apologize for. This one's not messed up at all. If quadrilateral PQRS is similar to to ABCD, find the scale factor. Now it has to tell you the order. PQRS to ABCD. So the scale factor of PQRS to ABCD. We're going to pick any side from PQRS, put it over its corresponding side in ABCD, and reduce. Scale factor is 1/3. Had someone else picked 11 and 33, you'd get 1/3. Someone else picked 18 and 54, you get 1/3. Someone else picked 7 and 21, you get 1/3. Make a scale drawing using the given scale. This means using a ruler and measuring it out. A basketball court is 84 feet by 50 feet. Well, let's draw that. Basketball court's a rectangle. The scale, we want to start our proportion by writing down the scale. 1/8 of an inch is equal to 2 feet. We have to convert 84 feet in real life to inches on a scale. We got to convert 50 feet in real life to inches on a scale. Let's do the 84 first. The reason we put 84 on the bottom, notice both the bottoms are in feet. That means both the tops are going to be in inches. You need that relationship. So let's say this is y. So first thing I notice, I have this complex fraction that makes me sad. I'm going to multiply the fraction on the left by 1. You're allowed to multiply by 1 anytime you want. I'm going to write 1 in the form of 8 over 8. Why would I choose 8 over 8? Because 8 times 1/8 is 1. 2 times 8 is 16. Now I don't have a complex fraction. To get y by itself, we're going to multiply both sides by 84. This gives me 84 over 16 is y. Does this reduce? Well, I can divide both of these by 4 and get 21 over 4. This is the only time, to my knowledge, I will ever ask you to write your answer as a mixed number. 4 goes into 21 5 times evenly. There's 1 left over. So it's 5 1/4 of an inch. Fractions, mixed numbers work well with rulers, with very little else. Figure out the length of x. We're going to take 1/8 of an inch over 2 feet is equivalent to x inches over 50 feet. Fraction on the left reduces to 1/16 again, just like I did before. If I multiply both sides by 50 to get x by itself, I'm going to end up with 50 over 16 equals x. We can divide the top and bottom of this by 2 and get 25 over 8 equals x. As a mixed number, once again, don't ever use mixed numbers unless you're using a ruler or you're cooking in the kitchen. This goes 3 times evenly, and there's 1 left over. So using your ruler, you'd make a rectangle that's 5 1/4 inch by 3 1/8 inch. If you don't know how to use a ruler, please come see me, and I will try my best. Please do the homework assignment for 7.2.